Welcome back to another Tech Talk Tuesday episode, actually on a Tuesday, brought to you by the Chemical Shelf. So, another day, another DIY EV wiring harness. So, as we jump in here, I'm going to review what we've done so far as we wire up the zombie verter. But basically, what we're trying to achieve is making our own fuse block essentially one piece at a time so that we can drive an EV vehicle. I think what's nice about this design is that this could work as a standalone or it could work in addition to your OEM fuse block. So you could take something like this and run it in parallel to what you already have, leaving everything else alone, and only take this as far as you need to run the inverter, the motor, safety box, VCU obviously. So as I mentioned in my prior videos, I would like for each one of my videos to stand on its own. I don't like referring people to this video and that video, unless it's just for extra information. But basically everything that you need to get through this video should be in here. So here I'm just adding a power source. This will act as our car battery. This is called the bench power supply, and I just like to fire it up to see if it's stayed on my preset voltage. You can preset these to volts or amps, volts or current. So car battery is approximately 13 something volts, although we call it a 12 volt battery. But you already knew that. So I'm going to turn this off. So here's how the stuff we have here works. Just want to make sure you guys can see it. So this is a input wire that will go from the car battery to our ignition switch, okay? So this is input. We no longer use alligator clips on our power supply because we learned we can just simply attach the wires to these studs. So that's how we do it now. So that goes on there. Again, this wire takes the power and puts it in our ignition switch, and then another source of power. This one goes to our fuse block, and this also runs to the car battery, like so, and it delivers permanent power to the fuse block. Jeez, fine threads, a mile of them. Okay, so that is the positive side. For the negative, okay, this is our negative lead. It will go from the VCU's pin 55 to the car battery. Right now, we have two hot leads, if you will, one going to ignition, one going to fuse block, and then a ground going to the VCU. We're going to continue on. So now we're going to take the permanent power through the fuse block, and I can cheat because I can look in the back here since I made all these wires red. That made sense at one time. So we take the permanent power. There's only one fuse in here, and all we need is one wire out of that fuse. And that goes to pin 56. And this turns on our VCU. Well, it puts it on permanent power, so it kind of puts it on standby. This is how the VCU lives in your garage, in your car, in the parking lot. It's always on standby. It has something to do with the internal timers. And in order to keep the internal timers going, it needs power.
Why is the VCU always on? Well, it's a little bit of a misnomer. It would be more correct to say that the VCU is always active. It's always powered up from the 12 volt systems within the vehicle. A few reasons for that. The primary one is that the VCU has within its software a real-time clock. And the real-time clock is there in order to enable timed charging. And it's something that I use quite a bit because I have nitrate electricity here. So I'll typically set my cars up to commence charging, at some ungodly hour like 3 or 4 a.m. Using the timer functions in the VCU. There would be other ways to do that. There can get into all manner of things like wake ups and low power modes and other kind of external clocks that wake the main CPU and all this kind of thing. Well, yes, there is a current draw from the VCU when it is powered from 12 volts that would be much higher than you would get from a typical automotive system. Okay, so a typical engine ECU or gearbox controller or these kind of things. Do I have any plans to update that? At the minute, no, honestly. I find it easier to keep things simple, and particularly with a piece of equipment as important as a VCU. The more simple that it is in not only its design but its use case, the less likely there is to be any kind of weird problem that I don't catch here and that ends up causing problems for somebody else. Let's say, this is a theoretical, let's say we had some kind of a wake-up system in there, and let's say that wake-up system went a bit gaga because maybe it's freezing cold outside or a little bit of moisture got in, and instead of waking the VCU to run a timed charging event, it decides to wake the VCU, fire up the high voltage system, fire up the drivetrain and apply full throttle. That would not be good. So simple things like this is where I tend to be at. Now, I know I'm going to have people screaming at the thing, but Damien, it runs my battery flat after 5 minutes. What am I going to do? There are these things called 12 volt battery switches, folks. Okay? I know it's not what you want to hear, but it's what I do, and I'll show them to you if you so wish.
All right. So far, so good. We haven't touched the ignition, we haven't turned the key or anything like that. VCU is in standby. I'm going to turn off the power supply. It takes a while to bleed down. I don't like connecting pins in here while it's on. And this VCU comes with a really nice connector here that goes on this header. But we're not using it on purpose so we can demonstrate what pins we actually use. And I'm actually going to let you guys in on a little secret here that will make the experts cringe, but so be it. So in the old days, we would refer to these two connectors as maybe A and B, okay? We no longer do that. They're kind of split in two, but they're seen as one 56-pin connector. But I'm telling you this because if you're intimidated by 56 pins, we can run and drive the car with not even all of the pins used up on one side, okay? I'm showing you this on purpose just to kind of reduce the intimidation. So you could run it like this. We'll put an asterisk next to that, and I explain it later. I think there's one pin on here that's important, but it's kind of optional. We'll get to it. But anyway, you could just focus on the B connector. In the old days, before the zombie, I would call the A connector the ancillary or auxiliary connector, and the B was the one that all the magic happened on. All right, so let's keep going. So we just ran our permanent power wire, and now we're going to take the middle fuse block here, which is ignition power. So this gets its power when the key is turned on to the on position, if you will. This goes to pin 15. I'm going pretty quickly through this because we've done this 1,000 times. And there's prior videos that I will show you screenshots and diagrams. Okay, that leaves us with the third row here, and this is the run or the start position. This is when we take the key beyond the on position and give it that momentary flick before it springs back. This is as if we were to engage the starter on a conventional internal combustion engine. And this goes to pin 52. Okay. So this brings us to where we are at today. And today we're going to be adding something called a forward and reverse switch Why are we doing this? Well, I explained this thoroughly in a prior video, but the Prius transaxle does not have a traditional reverse gear in the transmission. It doesn't have a reverse gear at all. So the way we go backwards is we have to take a switch and flip it in reverse and make the electric motor spin backwards. That's how we'll back up the vehicle. And then we can put this is in the neutral position, and then we can press forward and we can go forward. There are multiple options to set this up. This is an optional switch. There's other ways to do it, but I chose to go this route. And so today's video isn't about the theory of it or the why we're doing this. See the prior video on that. This is how to do it, okay? So the goal is to complete this fuse block to have a running and driving electric conversion. And the next fuse on here on the ignition row will feed this switch. So let's do it. I have a big surprise for you guys. I will not be crimping in this video. I decided to spare you the agony. So I already have pre-crimped and terminated wires here. The wire that comes into the ignition, I believe that was a black wire, and we're taking a sort of grayish red out of it. The colors don't matter, but that's going on here. Let me see if I can throw it in there and not look foolish. I finally get a click. Okay, and that will also get a 1 or 2 amp fuse, maybe a 3. These are all 2s. I've ordered some 1s, I've ordered some 2s, and I've ordered some 3s. And of course, I really want to get the 1s, but the 2s showed up. So that's what's in here. And then we take the other end, and it goes to the switch. So guys, correct me or let me know. Is this a 3-position switch? I honestly don't know. I'm calling this a 3-position switch. Maybe it's just a 2-position. Who knows? The feed into it, the input, as I call it, goes on the middle pin, like so. Okay? And then these two will be our outputs. What we're trying to achieve is we're adding 2 wires on 2 pins to the VCU. We are adding something on pin 53 and something on pin 54. Pin 54 is going to be our forward direction, and pin 53 is going to be our reverse direction. Those pins get 12 volts. When they see 12 volts, they will tell the VCU it's time to go forward or it's time to go backwards, okay? That's how we'll get the vehicle to move forward or backwards. So first I'm going to do pin 54 using a blue wire, and I want to show you just something quirky here. In order to do forward on this switch, you would think you put the wire on here on the top pin to match the top forward position. That's not how these switches work for some reason. You actually put it on the bottom pin, at least on this switch. I'm pretty sure they're all like it, but double check your documentation if any. So we got that on there, and the other end goes to pin 54. Okay? So now I bring out a green wire, and same as before, we want to wire the reverse, and the reverse switch thing here is on the bottom, so it actually goes to the top pin. Don't ask me why, it's just how it is. And then from here, the green wire, which is our reverse wire, will run to pin 54 on the VCU. Vehicle control unit, zombie, the brain, whatever we want to call it. I am doing this left-handed and struggling. Okay, and that's in there. Let me go get a fuse. All right, so we are continuing on, and we're putting simply a 2 amp fuse into this slot. This is on the middle, which is our ignition on position. All right, so I think we're ready to test. Let me get the trusty laptop out here. Okay, so first I just want to make sure the key is off. I hope you guys can see everything. Okay, so first thing we do is we turn on our bench power supply. This is just a testing facility, and the real application, the VCU would always have power like this. Okay, it's drawing very little current, 0.128 amps. So what, 128 milliamps? Is that what it's called? Okay, so it's supposed to be now advertising its network. And it is FairyLink, and we appear to be connected. So we're going to jump to a browser and open up the software for the zombie, which is from Open Inverter. And this is the menu system for the zombie. And the reason we need our laptop is so that we can see if switching the ignition key puts us in ignition on mode, and then clicking it further puts us in the run mode. So what I want to also demonstrate now real quick is that because we're using this forward and reverse switch, we need to go to parameters, and under parameters, it happens to be under throttle. There is a direction mode parameter, and mine is set to switch, as it should be. The other choices are button, default forward, etc. Okay, again, I explained all of this in the prior video, and Damien does a way better job of explaining it in his original video from the development perspective. Okay, so DIR mode is set to switch. So now we jump to spot values. Under spot values, first thing you'll notice, I upgraded to version 2.15a. I suggest you do the same. It just came out recently. I was excited to see what it offers. So I did an upgrade. There's also a video on how to do the upgrade. And here we've been over it 1,000 times. Op mode, operational mode, is off, as it should be. We haven't touched the ignition. But before we go any further, I want to show you a parameter that relates to this switch. And we're going to go over and over this stuff like a carousel to get ourselves in the mentality of working with the software in conjunction with the hardware, knowing how to troubleshoot with it, and so on. We're taking baby steps, but trust me, we will build up some knowledge as we go. So here, these aren't in alphabetical order. I wish they were, or we could maybe hide some. But there's this parameter called DIR for direction, and right now it says neutral. Makes sense. Car is parked in our garage, right? So we'll be watching this direction parameter as we flip the switch. First thing we're going to do is go back up to the spot values. I'm just going to click on spot values because my mouse is misbehaving. Okay, so click on auto to set the auto refresh, and then we have to click on refresh after. Once we see the donut here doing its thing, we are ready to do some testing. So I'm going to turn the key to on, and nothing happens when we turn it to on. Again, I wish the op mode switched to ignition on, or literally just on, but doesn't. So we click it once more. Bam, op mode turned to run. Okay, that's great. Let's go down to our DIR parameter. I'm going to make it be the first one. It's the first one on the list. I'll try to show this to you guys. We are under spot values. The first one on the list is what we want to watch, and that one says neutral. So now I'm going to click on forward. And look at that. The direction has changed to drive. That is so cool. I'm going to now flip it back to neutral. Went to neutral. And now I'm going to click on reverse. And it went to reverse. So now we can spin the motor in the opposite direction of forward. Note that it's not correlated to clockwise and anti-clockwise, okay? That's just a little side note. Okay, so now we're going to put it in neutral. there it is. The refresh, auto refresh, put it on neutral, okay? So this is it for today, guys. We're just building a little bit at a time. Uh, we will cover in the next video the next fuse on our ignition on fuse block. I think we're going to wire the safety box. There is a video on the safety box, which is what BMW calls its contactor box, the gatekeeper inside of its battery pack. If you haven't seen the video on that, it might be a good primer to watch that before my next video comes out, so you know more what we're talking about. And it's guaranteed to cure your insomnia. Let me turn this off. This should go to, obviously, to off mode. Thanks for watching, guys. I'll catch you in the next one.